Today we are going to introduce our dimensional analysis or unit conversions unit, and we are going to start by going over some scientific notation that you should have seen in algebra class, and we'll do some simple one-step conversions. All right, so first up, here's this video. We'll link it on Google Classroom so you can watch it on Google Classroom, but this is just a good visualization so we can start to see what we're talking about when we use scientific notation. So scientific notation, it is simply an easy way to write very large or very small numbers. So for example, if I wanted to write out the distance to the sun, that is 149 billion meters. So that's a lot of zeros at the end of that, if you see at the bottom here. Instead, we want, so if we're looking at the bottom here, 149 billion meters. Instead, we can write that as 1.49 times 10 to the 11th meters. So it's just a shorter way to write that number since it has a lot of zeros to it. If we go on the opposite end of the scale, so the radius of a hydrogen atom, so that's really, really tiny, that one you can see it's point and then all these zeros, 0.53 meters. And if I were to write that, it's 5.3 times 10 to the negative 11th meters. So it's just a way to write very large and very small numbers. If we want to go from regular numbers into scientific notation, here are the steps to follow to do it. First up, we want to locate the decimal point. If there isn't one, we draw it where it should be. Then we want to place the new decimal point after the first number that is not zero. So we're looking for a non-zero number. Then we count how many spaces we have to move that decimal point. That is going to become our exponent. Then we determine whether or not the original number was bigger than 1 or less than 1. That determines whether or not it's positive or negative on our exponent. So if we had a number that was larger than 1, then our exponent is going to be positive. If it was some decimal that's smaller than 1, then our exponent is going to be negative. When we write that, we write our new moved decimal number from the first two steps, and then we write times 10 to the power of whatever exponent we just determined. So here's an example of all of those steps in action. So let's say we have 453. So normally we would write 453 without that little decimal point at the end. So since it's not there, we're just going to put it where it should go, which is at the end of the number. Then we want to move our decimal place here over 2 spots. So we want one non-zero number, and then the rest can be after the decimal place. So we just move it over 1, 2 spots. So when we write this, since it moved 2 decimal places and 453 is larger than 1, we're going to say 4.53 times 10 to the positive 2. So in your notes, you will see a couple examples. So you can pause the video here and try and do those examples. And here are what your answers should be for those examples. The next thing to do is to go the opposite direction. So we want to go from scientific notation into just regular standard notation, regular numbers. The steps for this one, first we want to determine if the exponent is positive or negative. If it's positive, then we have to move our decimal place that many spots to the right. If it is negative, our exponent, then we have to move that decimal spot or that decimal place that many spots to the left. So let's say we have an exponent that says -4, it just means move our decimal place 4 spots to the left. When we have moved our decimal place, then we write the number with the decimal in the correct new spot. If we need to add in some zeros, we just add in zeros. So here is what an example of that looks like. Let's say we have this number, 3.5 times 10 to the third. If I want to write that as a regular number, first I just write down 3.5. Then I look at my exponent. My exponent is positive 3. So that means I need to move my decimal place 3 spots to the right. So when I do that, 1, 2, 3, move it over, fill in the missing spots with zeros, and now I have put my decimal place at the end of that. So 3.5 times 10 to the third, that's just the scientific notation way of writing 3,500. So again, there are some examples in your notes. Pause this video here try to do those examples and then unpause when you want to check. Here are the answers to what is in your packet. And that's it. There's also at the bottom of your notes, you'll see a website linked there. If you want some more practice with this, you can go to that and that will help you practice. It's just some more practice problems with all of the scientific notation going back and forth.